of this expansion, x plus 4 to the 4th power. Okay? So, this is my first term, and that's my second term. So that means my 4 is going to have the power of 2. How do I know that? Is because this is the third term. Okay? So this 4 will always be power of 2. On the fourth term, the power will be 3. And the x, this power here, depends on this power. But remember, it's got to add up to 4, so that's got to be 2 also. And then my factorial is 4 factorial on the top, because it's a 4th power. And then the bottom factorials come from these two exponents, so 2 factorial, and then you are done. If you try to simplify and make a mistake, I'll take points off. If you leave it there, you get full credit. Okay. Alright. Let's go from 11 through 30. If you've seen one, you've seen them all. It's all the same, so pick a few. Yes. 12. Yes. 30. 23. 26. Alright, let's start with 12. Let's take a look at that. I have a 2a plus 1, and that is raised to the 7th power. I don't want this done using Pascal's triangle. I want this done using the binomial theorem. So this is 2a to the 7th power is my first term, plus my second term would be 7 factorial over 6 factorial times 1 factorial. Remember, these two numbers have to add up to 7 each time now. Okay, and then 2a will be to the power of 6, and then I have a 1 to the power of 1. And you don't have to write the 1 if you don't want to. Then I got a plus 7 factorial over 5 factorial times 2 factorial. And then 2a will be to the power of 5, and then 1 will be power of 2. Okay, and then plus. I have a 7 factorial over 4 factorial times 3 factorial. 2a will be the power of 4, and then 1 will be power of 3, plus 7 factorial over 3 factorial times 4 factorial. Okay, and then 2a will be power of 3, and then 1 will be power of 4, plus 7 factorial over 2 factorial times 5 factorial, and then I have a 2a to the power of 2, and 1 will be power of 5, plus 7 factorial over 1 factorial times 6 factorial, and then 2a will be power of 1, and then 1 will be power of 6, and then that is it. I got one more term, and that's 1 to the power of 7. That's it. You don't have to simplify. But if you do choose to simplify, make sure you don't make any mistakes, because then I'll have to take points off. So the moral of the story is quit while you're ahead. Well, hello. That's questionable. 23. 4u to the 3rd plus v to the 4th. Alright. So I have to expand this. I'm going to have a 4u to the 3rd, it'd be to the 4th power. That starts it. And then next term is going to be 4 factorial over 3 factorial times 1 factorial. And this time 4u to the 3rd will be power of 3, and then v will be the power of 1, plus 4 factorial times 2 over 2 factorial times 2 factorial, and then I have a 4u to the 3rd will be the power of 2, and then v to the power of 2, plus. Okay, then I have a 4 factorial times 1 factorial times 3 factorial, and then I have a 4u to the 3rd to the 1st power, and then v to the 3rd power. And finally, v will end up being the 4th power, and that's the end. There's a pattern here. Hope you guys can see this. Alright, 26. You have a plus 3b to the second, a to the third power. Alright, so this is going to start out with a to the third, and then I'm going to have a plus 3 factorial on the top, and then I'm going to have a 2 factorial times 1 factorial, and then a will be to the second, and then I have a 3b to the second will be to the power of 1 plus 3 factorial over 1 factorial times 2 factorial, and then my a will be to the first, and then 3b squared will be to the second, and the last term is going to be 3b squared is to the third, and that's done. Piece of cake. Alright, let's go to continuous growth, decay. Let's start with section 42, compound interest. 43. Section 43, compound interest. I only have 1, 2, and 3. Section 43. What's that? I did one of the notes, yes. Alright, so, yes, Stacy? 3. Alright, Stacy, you got a calculator for me? Okay, so you're going to help me out. Okay, this is section 43, number 3. Okay, it says Charlotte deposited $1,000. Okay, and this is going to be your principal. That's what you're going to put in. Okay, 3 years ago. So that means my time is 3. The account is now worth, okay, so the amount now is up to $1,276. And this was compounded continuously, so you have to go to the PERT formula. Okay, A is equal to P-E-R-T, and plug in everything that you have. I have my A, which is 1276, have my P, which is 100, and my E is raised to the power of, I don't know what the rate is because that's what we're trying to find out, times 3R, because time is 3. Alright, I'm going to divide both sides by 1,000, so that's going to give me 1.276 is equal to e to the 3r. I need to solve for an r, but it's in the exponent, so I will have to do what to both sides? ln. That's why we use ln. See how ln just kind of makes the e disappear for us? If you use other logarithms, then it wouldn't. Okay, that's why you're just better off just using ln all the time. 1.276 is equal to 3r. Okay, therefore my r, the rate, will turn out to be ln at 1.276 all that over 3. Now you should get a picture of this. ln of 1.276 is going to be positive. How do you know that? Because you should know the graph of ln, and that's 1. So 1.276 is going to put it somewhere up here. Okay? And then you're going to divide that by 3. So, Stacy, what is ln of 1.276 divided by 3? 0.08. So that means she got 8% interest. Okay? So the rate is equal to 8%. Alright. Let's do some more continuous growth and decay. So let's go to section 44. And Ariel, did you say number 10? Okay. Yes. Number 11. Yeah, you're going to nursing school. You're going to see this a lot. 12. You'll see this a lot in biology. Yes. 12? Right. Alright, let's take a look at 10. You have a radioactive substance that is decaying. Decay constant is, okay, K is equal to negative 0.0235. Find the half-life of the substance. So that means, how long does it take, we're trying to find out what T is, for the material to go down to half of what it is. Okay, so in the interest, we use this formula, A is equal to PERT, but all the other times, the same formula, it just becomes Y is equal to CEKT. And then you just put in the information that you have. Right now, I know it's a half-life. So that means half-life means Y is half of what you start out with, means half of C, because C is what you start out with. E to the negative 0.0235 T. Okay, so we're solving for T. The C doesn't bother us because when you divide by C, you're going to get 1/2 is equal to negative 0.0235, oops, E to the. Alright, now I gotta bring this thing down into the front. So that means I'm going to ln both sides. So ln, okay, of 1/2 is equal to negative 0.0235 T. So therefore my T is equal to ln of 1 over 2, all that over negative, okay, 0.0235. Alright. Ariel? This is your problem. $29.496 years. Okay. You're welcome. Number 11. Okay. Radium-226 decomposes radioactively. Its half-life is 1800 years. So that means the T is 1800 years. Okay, find the decay constant, then compute the amount. So first of all, we got to find K. And then they want you to find out, okay, the amount of radium you have in 100 years. If you start out with 2 grams. So they say if, okay, C is equal to 2, okay, and T is equal to 100, okay, they want to know what is the Y. Okay, but before we do that, we got to find the decay constant, which is the K. So, again, Y is equal to, okay, CEKT, but since this is a half-life, this becomes 1/2 of C is equal to CEKT, and when you plug in what you have, this becomes 1/2 of C is equal to CE to the 1800 K. Divide both sides by C, you're going to get 1/2 is equal to E to the 1800 K, and ln both sides, you're going to get ln of 1/2 is equal to 1800 K. So my K is equal to ln of 1/2 over 1800. Okay, I solved for K. Now notice I didn't go into a decimal right now because I don't want to generate what's called a round-off error. Okay? So because I have to go find this value, so I'm going to have a better answer or a closer answer than if I don't turn to decimal. So I'm going to leave this thing as is. I'm going to have Y is equal to, okay, C is 2 grams, 2, E to the ln of 1/2 over 1800 times 100. Okay, I just plugged into my formula right here. So these zeros are going to cancel out. So that is going to give me y is equal to 2 times e to the ln of 1/2 over 18. Alright, now you can go ahead and do that. So, what is ln of 1/2 divided by 18 to 3 decimal places? Eva? .92 what? 0? Okay. Negative what? 3/8. You guys using Twitter language. JK, my B. Yeah, JK. Alright. And when you raise that to the power of that and then multiply by 2, it turned out to be 1.92 grams. Do you think so? Okay, thank you. Alright, Tony, you got a calculator for me back there? Alright. Number 12. A city in California, we'll call that Rancho Penasquitos. It's not a city? Suburb. Alright. Has 23,286 people in 1990. Okay? And by 1998, okay, then it has 28,753. So anything living thing that is growing and dying, we're going to use exponential growth. Okay? So, this is 8 years. So that my time is equal to 8 years. And this is my C. And this is my Y. Okay? And assuming the exponential growth, find the growth constant and estimate the population in 2007. So we want to know what the population is in 2007. So 1990 to 2007, that implies my T is equal to, what, 17 years? Okay, before we can find out what it is 17 years later, we got to find out what the K is. Okay, how fast is PQ growing? Okay, so we're going to use Y is equal to CEKT. Plug in all the information I have. That means this turns into 28,753. Okay, and this is 23,286. E to the K, I don't know what that is 8K. Okay, divide both sides by 23,286. So 28,753 divided by 23,286 is equal to E to the 8K. Alright, Tony, what is this value right there? One point what? 137. Thank you. That is E to the 8K. Again, what are we going to do now? ln. ln of 1.137 is equal to 8K. So my K is equal to ln of 1.137 over 8. And I want to leave it like that for right now because I don't want to have a round off error. So my y, my function now looks like this. Y is equal to 23,286 e to the ln of 1.137 over 8 times 17. Alright, Tony, I want you to do this. I want you to find ln of 1.137, multiply that answer by 17, and divide that answer by 8, and tell me what that is. .2728. Okay, we'll call that 3. Okay, now I want you to raise e to the 0.273 and multiply that answer by 23,286. Are you still with me, Tony? 30595. Do I have a decimal? What is it? 1. Alright, now, the reason I put the decimal there is because I want to show you something. These are people. So you don't round down, you don't round up people. Anything that is living, you just have to cut it off. Okay, truncate, that's the word, magic word. You truncate that. So this is going to be the final answer. You always truncate anything that is growing, yes. Now you tell me. Okay, so where is the error? Okay, where's my error? Where's my error? It's not 0.273? It is not? Okay. So instead of 0.273, what is that? The ln of 1.3. Okay. That's 5 right there. Is that what it is? Well, 1.235. Okay, 1.235. 235. Alright. That's a mess. Okay. And then what will this power end up being? E to the what? What is ln of 1.235 divided by 8 multiplied by 17? Or multiplied by 17 divided by 8? .4485, so 0.44, no, 449, right? Yeah. And what do I get when I raise e to the 0.449 and multiply by 23,286? $36,483 people. Did that round to 4.449? What did you get? 0.44. What did you get? 812. So you just want me to change that to 8. But if that's the right answer, then that's the correct rounding. She's got 8, 5. You got 8, 1. Okay, let's do it your way. Tell me what the population is. 51. So there's like 32 people difference. What the heck? They're just people. Yeah. But that's why you get graded for your work, not for the final answer. Because depending on where you're rounding and where your calculations are, you can get different answers. Alright. Let's go. Sequence and series. Yeah, 1 through 23. That's it. Section 41. All the problems are coming from section 41. If you can do those, you're in good shape for sequence and series. 19. 18. 23. Alright, 19, 18, and 23. Alright, last three. If you get quiet, we can get done really fast. Let's start with 18. 18. This is summation notation. You're starting at n is equal to 0. You're going to 4, and you're going to have 8 times negative 1/2 to the n minus 1. Okay, and you will see this if you take SAT too. This is summation notation or sigma notation. Now, when you see a number only going to 4, you're just better off just finding each term, just adding them. Okay? Now, if this went to 4,000, then you better use the formula. Okay. So right now, I'm going to plug in 0. So when I plug in 0 for n, that will be 8 times negative 1/2 to the negative 1 power plus. And then when I plug in 1, that will be 8 times negative 1/2 to the 0 power. And then when I plug in 2, that will be 8 times negative 1/2 to the 1 power. When I plug in 3, that will be 8 times negative 1/2 to the 2. And when I plug in 4, and that will be my last term, is 8 times negative 1/2 to the power of 3. Just clean it up. That just flips the negative 1/2. It becomes negative 2, so it becomes negative 16. This is just 1, so 1 times 8 is 8. So the next term is going to be 8 plus. This is going to be 1/2 of negative 1/2 times 8, which is negative 4. Okay. Plus. This is going to square that. 2 on the bottom, that becomes 4. So negative 1/4, with negative 1/2 squared is going to give me positive 1/4, so that'd be 8 divided by 4, that becomes 2. And then finally, when I cube this, I get 8 on the bottom, the negative still stays, so that'll become negative 1. Just add them together, you got the answer. Add them together, you got the answer. What is it? Can't add? Negative 11? Alright, 19. That better be the answer. Negative 10, negative 16, negative 4 is negative 20, negative 21. Negative 21 plus 10 is negative 11. Alright. Last two. 19. Number 19 says the eighth term, if you add 8 terms, you get 42.5. And they tell you the ratio is 0.5. Okay, they want you to find, okay, a sub 1. Okay, so this is geometric series because I have a ratio. So my formula is S sub n is equal to a sub 1 times 1 minus r to the n, all that over 1 minus r. That is my formula. I have to memorize. You have to memorize that. Okay, I will not give you that formula. So you have a sub 1 times 1 minus r, which is negative 0.5, okay, to the 8th power, all that over 1 minus negative 0.5. And when you calculate that, that better turn out to be 42.5. That's what they're saying. 2 negatives become positive. Okay. This now becomes a sub 1. Since I don't have a calculator here, I'm going to go 1/2, negative 1/2 raised to the 8th power. What is that? 200 and something? What's 1/2 raised to the 8th power? 1 over 200. What's 2 to the 8th? 256. So this will become 1 minus 1 over 256. All that over 3 over 2 is equal to 42.5. Alright, you can do it in decimal if you choose to. Okay, what is 1 minus 1 over 256? Negative 255 over, that's right, 256. Okay, so you're going to have to divide 255 by 256 and then divide that answer by 1.5. So what is that answer? 255 divided by 256 and then divide that by 1.5. Come on. No, 3 decimal places is fine. So, I'm assuming that is correct. That's what I have. So what's my last step? Divide by 0.664. So a sub 1 is equal to 42.5 over 0.664. And what is that? 54? 64? $64. Probably is 64 because my ratio is 1/2. It's going down after this. So, all right. The last one is 23. All right, Ben, would you read number 23 for me? Somebody lend Ben the packet. Okay, so the length of the arc of a pendulum, that's 120 meters, okay? Millimeters. Okay, so if it goes by 10%, then the next one will be 90% of the previous one. So my rate is going to be 0.9. Okay, because it's decreasing by 10%, so my rate will be 0.9. the 90% of original one. So basically what I have is 120 plus 120 times 0.9 plus 120 times 0.9 times 0.9 plus 120 times 0.9 times 0.9 times 0.9, and then we're going to go on how far? Forever and ever and ever. Okay, well, what's my ratio? Ratio is 0.9 or 9/10. What's my a sub 1? Okay, it's 120. How far, technically, if there's no friction, how long will the pendulum swing? In space, it will swing infinite number of times, okay? So therefore, this is infinite geometric series, and that is a sub 1 over 1 minus r, so it'd be 120, all that over 1 minus 9 over 10, which is 120 over 1 over 10, which is 1, 2, 0, 0. So, what it's saying is, if it keeps going forever and ever and ever, it will never go beyond 1200 millimeters. Okay? It'll get closer and closer and closer, but the maximum is going to hit, yes. 0.9, okay? So, first one's going to be 120. The first swing is going to be 120, okay? And then the second swing is going to be 9/10 of that. So tell me what 0.9 times 120 is. Calculate that for me. 108. Because then the next one's going to be 108 times 0.9. Calculate that for me. 97.2. So it's going to go on like that. What it's saying is, this is 10% less than that, and this is 10% less than the previous one. Basically, it's 90% of the